A cryptocurrency has a distributed ledger called a blockchain. The blockchain keeps track of every transaction that occurs across the cryptocurrency. This blockchain must stay up to date and verified, which requires someone in the network to do that validation. Bitcoin and Ethereum use the proof of work algorithm. Miners do computational work to validate the legitimacy of transactions across the network, and in return, those miners are given cryptocurrency as a reward for that computational work. In the future, cryptocurrencies could move towards a proof-of-stake model. If you own a significant amount of cryptocurrency, you have incentive to keep the validity of the blockchain up to date. Proof-of-stake algorithms can be significantly less energy-intensive than proof-of-work algorithms. Vlad Zamfir is a researcher for the Ethereum Foundation, and he studies cryptoeconomics. He joins Haseeb Qureshi for a conversation about cryptoeconomics, which is the system of trade-offs and incentives around cryptocurrencies. You can send us feedback on the show by emailing me, jeff@softwareengineeringdaily.com, or joining us on the Slack channel at softwareengineeringdaily.com/Slack. We would love to hear from you. By the way, I recognize the audio on this episode is not perfect, so we decided to not air ads on this episode. The conversational content is fantastic, and I think you will benefit from tuning in. Most of the other episodes have some better audio quality, including lots of other ones with Haseeb, so check those other Haseeb episodes out. Let's get on with this episode.
Vlad Zamfir is a researcher for the Ethereum Foundation. He's a mathematician and statistician by hobby, he made me clarify, and is the chief researcher behind Casper, Ethereum's new proof-of-stake-based consensus protocol. He's an active blogger and speaker and writes a lot about the field of cryptoeconomics. Vlad, welcome to Software Engineering Daily.
Hi, Haseeb. Thanks for having me.
Yeah, of course. I'm really excited to talk to you, actually. So one new area of research and development in the world of blockchains is what's called cryptoeconomics. And cryptoeconomics is sometimes described as the intersection of distributed systems, economics, game theory, and cryptography. Let me start by asking you, how would you define cryptoeconomics?
Sure, yeah. So from my point of view, cryptoeconomics is the application of incentive design to problems that are traditionally cryptography and distributed systems problems. So basically, there's like certain type of problems that like crypto and distributed systems people will look at, like information security problems, like things where they want like protocol guarantees, and like there's like kind of security against adversaries, right? And so basically there's this kind of crypto methodology that involves like adversarial thinking and distributed systems kind of thinking, where like now we get to add this new thing to our toolbox, which is this incentive mechanism design thing. And so to me, cryptoeconomics is incentive mechanism design added to the kind of cryptographer/distributed systems like toolbox.
Right. And so there's a lot of intersection with cryptoeconomics and game theory. A lot of our viewers are probably familiar with distributed systems, familiar with economics, less familiar with game theory and what interaction game theory might have with something like a distributed system. Can you talk a little bit about what game theory is and how it applies to cryptoeconomics or blockchains?
Sure. So game theory is kind of a discipline or like a whole class of methods and approaches for understanding how players play inside a game where they're trying to win or like increase their revenue or basically maximize some payout that's like defined in the game structure. And you like game theory kind of started, with John Nash and the concept of like a Nash equilibrium. That's really like the most famous concept in game theory. And it basically says that like a set of strategies chosen by a set of players is a Nash equilibrium if given that everyone knows everyone's strategies, no one has an incentive to deviate individually. So like kind of given that everyone's strategies are fixed, like no one has an incentive to change their strategy.
So how does that apply to blockchains?
And so there's the game theory is about kind of predicting how people will behave when they behave rationally, or what kind of situations are possible when people behave rationally. And blockchains are incentive systems, and so we might want to use game theory to think about how people might deviate from the protocol that we set out, in order to maybe increase their payout, which is itself defined by protocol. at least for like a blockchain, for example. So like a blockchain protocol says, hey, make blocks here and like be, like participate in the consensus forming process, and like here's the rewards. And the question is kind of like whether people have an ability to game these rewards by deviating from the strategy and not behaving honestly. And there's like this great paper, selfish mining paper by Zamfir and Itai that like showed that like for proof of work blockchains, like following the protocol isn't a Nash equilibrium, which basically because they show that you could kind of, instead of publishing a block when you found it right away, you could rationally keep it and mine on it a little bit first, and you'd get a slight edge over the over other people with the protocol, and which could turn into like actually higher returns for you. And so like long and short of it, we use game theory to analyze cryptoeconomic systems.
It sounds like then in applying game theory to a cryptoeconomic system, you're assuming that the people in the system are basically rational actors and they're going to do what's in their best interest, and that plausibly they know what other actors are doing. Yeah. Is this a good way to model blockchains?
So that's what game theory does, right? Mm-hmm. The thing that we're doing when we design blockchains is we're doing mechanism design. We're kind of designing incentive systems to try to get certain outcomes. And the only way that we can really do that is with behavioral models that say kind of what outcome will happen from a particular incentive system. And game theory is kind of one thing in our toolbox for understanding what behavior might arise from an incentive system. It's, not be all end all, but if you can't, if the thing, it's kind of a red flag if the game theory doesn't work out. So, we want to have our system be, to our system look good under various kinds of analysis, including.
That makes sense. Okay. Now, combining cryptography with game theory is an interesting idea as well. So what does cryptography give you that doesn't exist in a normal economic system that you might analyze with game theory?
Yeah. So this is interesting. So I think now I don't think you're really asking about cryptoeconomics as much as how does cryptography influence mechanism design and game theory more generally.
Sure.
So cryptoeconomics is game theory mechanisms that apply to crypto. You're kind of asking about like the vice versa, right? The crypto applied to
absolutely.
Game theory.
Yeah.
And it's totally interesting there also. But I just want to be clear that like I don't think that's cryptoeconomics. But basically, there's a whole host of incentive mechanisms that may be possible with cryptography that aren't possible without them due to the limitations of the incentive mechanisms, right? At the end of the day, incentive mechanisms end up not being just kind of like this mathematical representation, but some program that has to like authenticate messages on a network, realistically in a digital world, right?
Right.
And so cryptography ends up being kind of necessary for implementing incentive systems. That said, it may or may not actually end up informing the design of them, right? It might be more about implementing the design in a way that, makes sure that the design is carried out as opposed to it being insecure and the incentives being distributed in a way that wasn't intended by the mechanism designer.
Sure. So I guess my motivation in asking that question is I kind of want to build in our audience just a kind of intuition for the kinds of things you can do in designing incentives that normally wouldn't make sense if you didn't have cryptographic primitives available, right? So things you can, for example, force people to prove or force people to give evidence of that in a normal economic system would just be totally infeasible. Right. Can you give just some examples to sort of build up?
But those are actually examples. Those are examples of cryptoeconomic stuff a lot of the time, actually, where basically what you want to do is to incentivize people to provide services in a distributed system and to prove that they're doing it.
Yeah.
And that's, I think, closer to the scope of cryptoeconomics, where you're kind of using incentives to get people to do things for a distributed system. And, in some way, people use reputation in the regular economy and also audits and all sorts of processes to prove that they're doing what they say they're doing to the people who are buying their products. But, in our kind of cryptoeconomic setting, we're kind of thinking more about like, we have like computers on the internet and they are going to provide services in a market, and pay for services in a market. And we want like the market to, not scam either participants. We want someone to be able, like, if I'm paying for a random stranger to store files for me, I want to know that they're actually doing it, right? When that's something that like may be possible with cryptoeconomic techniques, whereas right now we kind of need to rely on trust in Amazon or Dropbox or whatever.
So can you give just like a really brief example of how something like that might work? Like a proof that you still have a file that I'm asking to distribute?
Well, I mean, so that's kind of like a crypto proof. There are crypto proofs of various kinds to show that you have a file.
Mm-hmm.
And you would basically, you could imagine being paid to produce a new one of those proofs at a regular interval, and basically like that combined with an anti-Sybil mechanism, so that like people when you're paying people to store your file, you're not just paying the same one.
And real quick, what is a Sybil?
You have some redundancy. Right. So a Sybil attack is a classic problem in distributed systems. It has to do with an adversary that spins up a lot of nodes, or it's also a problem in reputation systems where an adversary will create a lot of identities. And so Sybil attack basically means it's basically an attack where someone creates a lot of entities or to like participate in the protocol. So in this case, you might want like a whole bunch of people to store your files because you don't want like any one of them to like fail and then you lose your files. And so you might want to say like, a bunch of people to place deposits in order to participate in the system of serving files. The deposits kind of guarantee that they are distinct because there's some cost associated with having that deposit, or like provide some amount of assurance that they're distinct, and then the cryptographic proofs can provide some assurance that they're holding the files, and that's kind of like an example.
Right. Yeah.
But this is just something like I'm not I'm sure that if you want to actually go and implement it, there's going to be a lot more details than I've just brought up.
Sure. No, my goal there was just to kind of give our listeners an intuition for just the fact that there are a lot of different things that you can do in a cryptographic or in a cryptoeconomic system that you just kind of can't do in other systems. Like there are new primitives that are available to you in designing this kind of an economy that I think are potentially more reliable, potentially more efficient in the limit anyway. And that it's a new set of ideas that people are thinking through, which is not immediately obvious to a lot of people.
Yeah, I think Bitcoin is like a really good example of this like system, but which is like simultaneously like applied economic concepts to distributed systems and created a whole new host of economic concepts that people are excited about. So Bitcoin is really like an educational tool about both digital currency and what that means for society, and also digital currency and what that means for distributed systems.
Right.
And I think that both are super interesting. But I like to talk about them kind of separately.
Makes sense.
Just so that people don't get confused about what cryptoeconomics is. Because, I think there's a whole field of people who do mechanism design. And we can't just call all of that cryptoeconomics because we're using cryptography.
Right. So kind of switching gears a little bit, what is a shelling coin? Can you describe that concept for me?
Oh, sure. Shelling coin. There's a concept called a shelling game, which basically just means it's a fancy way to say a coordination game, which is a game where people want to like make the same decision, but they don't necessarily have a lot of information about what decisions they're going to make, and so they use focal points. And so like a shelling coin is this concept that like you could basically have people report on value for some like external thing to the blockchain, or like and kind of because they're not coordinating with each other, they will all like fairly and honestly report the value. And you can kind of pay them if they agree, or pay the ones that agree more with them, more with each other, and pay the ones that don't less, or maybe penalize them. So like the idea there is that like by using this kind of solution concept in game theory for coordination games, we might be able to secure Oracle system that can provide data feeds for a bunch of stuff.
So just to be clear, why do we need that? Why can't we just directly get data feeds from off the blockchain?
Well, firstly, the blockchain doesn't have access to data that's external in the world. Like the data needs to be provided to it somehow. And if like a single party provides it, it might be more questionable. But I should say that shelling games are not like a cornucopia. They have failure modes. Like there's like you basically are relying on the assumption that two assumptions. One of them is the players can't coordinate, and B, the players share the same focal point for like the true value of the thing. And B seems not unreasonable, but the first assumption that the players can't coordinate is questionable, and becomes more and more questionable the higher stakes the game is.
Makes sense. So decentralized prediction markets tend to use shelling coins. And that's the way that they kind of report on real world events. So just again to kind of reiterate what you said earlier, let's say that we're trying to figure out if Barack Obama or not Barack Obama, sorry, Hillary Clinton or Donald Trump won the election. A blockchain doesn't directly know that, but one way that you can kind of establish this using a shelling coin without having a single party that's reporting on what's going on in the real world, you take a bunch of people who are ideally disconnected from each other and you ask them to try to converge on a value, and those who don't vote with the majority get punished, and those who vote with the majority get some kind of reward, which incentivizes this kind of trustless coordination. Is that a fair characterization?
Yeah, I mean, that's the intention, that's the design. The extent to which it's reliable has yet to be seen.
Okay. Are there known attacks against shelling coins or these kind of protocols?
You just coordinate with everyone to agree with each other on something that's not the true value.
Right.
Especially effective in prediction market, because you can potentially get a lot of reward for the market, or everyone sees that Trump won, and so everyone's kind of betting the bets change in the market before the Oracle reports possibly, right? And then the Oracle can just report wrong and take everyone's money.
Have these kinds of attacks been seen in the wild? Do you know?
No, I mean, most of these systems are still, I mean, A, I wouldn't really know, and B, most systems are kind of still too nascent to, I think, have had enough experience for people to figure out how to game the system, right? I mean, so a game comes into the existence, people figure out how to they kind of start playing the way it's intended before they eventually figure out how to deviate in a way that benefits them.
Right.
It takes time for people to figure out how to game their incentives.
Mm-hmm. And so one other concept is what's known as a stablecoin. And a stablecoin is a coin that's supposed to be pegged to some real-world asset, such as USD or some unit of gold. How do stablecoins work on blockchains?
Well, there's different kinds of stablecoins. I mean, there's cryptocurrency collateralized stablecoins, and there's externally collateralized stablecoins. All stablecoins basically need to have two kind of properties. One of them is that they can be issued, and the other is that they can be redeemed. And it basically means that if you want to buy some of this coin, maybe say I'm buying a gram of gold worth of stable coin. So basically I need to be able to put money down, put money somewhere. That money needs to do something. And then whenever I want to redeem, I get a gram's worth of gold worth of money out. So there's multiple ways it could work. One of them is, okay, put the money in, someone receives that money, they go out on the market, they sell it, they buy gold. They put the gold in a vault, and then when I redeem, they will give me the gold or sell the gold and give me, and then I can kind of have this asset. Another way that it can work is with collateral. So I might be willing to pay a price to hold to have someone, or sometimes they'll actually pay me to collateralize the gold coin that I'm buying. Mm-hmm. So maybe you can imagine that I buy a gram of gold with a digital token that's worth a gram of gold, and it's got 4x that dollar amount of Bitcoin behind it, or Ether, or some cryptocurrency. And then as long as the price of that cryptocurrency doesn't fall by a factor of 4, then when I redeem, there's still enough cryptocurrency there for me to withdraw. But if someone is going long on cryptocurrency, they actually find that quite agreeable, because they think that the amount of cryptocurrency that I put in will be less than the amount that I take out when I later redeem my gold coin. So they would rather be in crypto. They can basically increase their exposure to cryptocurrency and allow me to hedge and kind of have exposure to this gold coin. But this is called a contract of difference, and all cryptocurrency collateralized stable coins kind of have this property that if the collateral falls too much in price, then the redemption isn't going to be possible at the full face value of the gram of gold or whatever it is.
Right. So how robust do you think these stablecoins can be in the long run?
Well, that's also a very good question, and it's hard to say. I think cryptocurrency collateralized stablecoins can be quite robust. I mean, you just have to have enough collateral, but the issue is that the collateralization comes at a significant cost, and that means that there can't actually be that much of it in circulation. Externally collateralized stablecoins have all sorts of external risk, right? Risk that isn't just on the blockchain, isn't just cryptocurrency price risk. It's risk more to do with things like, your ability to get gold out of the vault, your ability to buy and sell gold, your ability to not have your gold seized by anyone,
right?
Or whatever assets are collateralizing these coins.
Which schemes do you think are the most promising?
It seems well. I mean, I think both are. I mean, I think at the end of the day, we're going to have all of them, and then you're going to have like baskets of stable coins that are like, or stable coins that are collateralized by stable coins. So that we have like a cryptocurrency collateralized stable coins, and externally collateralized stable coins, and people who make stable coins are collateralized for both of them, and then we kind of end up getting like these indexes. That's kind of my little prediction, but at the end of the day, what I'm saying is like I think we kind of need all of them because they're not all like 100% correlated risks, which means that it's better to have more of them.
That makes sense. This seems like they are very different risk profiles, but probably useful to have both in the ecosystem. Right.
Of course, yeah.
Cool. Well, from that topic, I want to veer a little bit to talking about proof of work and then eventually moving on to proof of stake. So I'm going to assume that our audience is familiar with how Bitcoin is secured by proof of work, but just to kind of really, really briefly go over it. So the basic idea of proof of work, also known as Nakamoto consensus, is this idea that there's a sequence of cryptographic puzzles which have dynamic difficulty. The first person, usually, who solves the puzzle gets to write the next set of transactions into the blockchain and earns a reward. Is that basically correct?
Yeah, that's pretty much right.
Cool. Sorry, go ahead.
Yeah, I mean, no, that's totally right.
Okay. So are there any other features of proof of work that are important to understand when thinking about proof of work and the transition to potentially proof of stake? Like, what are the problems with proof of work?
Yeah, so I mentioned one earlier, which is that it's not a Nash equilibrium to follow the protocol. And like that's a pretty serious problem, I think, just from the point of view of like, wouldn't it be nice to have a protocol where it's actually an Nash equilibrium to follow the protocol, or even better, a dominant strategy to follow the protocol, or even better, like a strong Nash equilibrium to follow the protocol, which is basically like a Nash equilibrium where instead of individual deviations, like groups of players can like deviate together and then redistribute their payouts to each other.
Right.
And then even better than that would be this kind of coalitional dominant strategy where basically you can get, no matter who you're colluding with, like it doesn't matter what anyone else is doing, your dominant strategy is follow the protocol. Right. So like that kind of thing would be really nice, but you can't really get it in proof of work because of the limitations of proof of work. Some of the limitations are actually fundamental. Like the fact that you can do selfish mining isn't fundamental because like you can make proof of work architectures that don't have that problem. But the fact that, say, a majority of the hash power could censor blocks is something that is going to be necessarily true in all proof of work systems, and it's going to necessarily be profitable because proof of work can't really tell who is meant to be censoring blocks. Sorry, who is meant to be producing blocks. They can't really tell when blocks are missing. At least the kind of traditional, anonymous, outsourceable proof of work, where kind of anyone can produce the proof of work. There are proof of work systems where you kind of specify identities that have to produce the proof of work, but those start to look more and more like proof of stake systems. But anyway, so what I was basically just saying is Nakamoto consensus, Bitcoin's protocol, doesn't reach like all of the optimality that we can imagine in terms of mechanism design and game theory. Additionally, it doesn't have some of the stuff that we'd want from consensus protocols. It's a consensus protocol, but it doesn't have any kind of notion of finality, any kind of notion of, the fact that blocks will never be reverted. I mean, it kind of does. I mean, it has a little proof that they will be reverted, but that only holds if in a partially synchronous network. So,
sorry, can you elaborate a bit there?
So yeah, so there's a couple of things. So firstly, let me say that the way that Bitcoin works is that if everyone tries to hash within this blockchain, and you to add the proof of work to it, and everyone picks the proof of work blockchain with the most work. And if someone were to produce a proof of work blockchain with more work that doesn't include a sum block, then that block would suddenly be gone from the history. And that kind of reversion doesn't really happen in traditional consensus protocols. But there's this proof that there's this proof that that Satoshi gave, that if there's less than half of the the mining power dishonest, then that won't happen. Now that proof relies on an assumption about the rate at which blocks propagate and the rate at which people find blocks. And this is kind of what I was referring to with partial synchrony. There's a great deal of research in consensus protocols to try to figure out how to reach consensus without making, or like have consensus in a safe way without making assumptions about timing. Whereas proof of Bitcoin and proof of work is a partially synchronous protocol, which means that it makes some, arguably pretty weak, but still some pretty significant timing assumptions. I mean, the whole idea of a hash rate is a very synchronous thing, right? The fact that we have a block time that's every 10 minutes is a very synchronous kind of thing. And those are things that traditionally we don't necessarily want in a consensus protocol. Normally what we want is something called asynchronous safety, which means that like no matter how crazy people's clocks run in the future, no matter how fast or slow people's processes terminate, no matter how fast or slow messages get across the network, we still will have the property that this block will never be reverted. And that's something that you just don't get in proof of work, because proof of work is not asynchronously safe. It's always going to be the case that block can be reverted if someone was able to like run their process arbitrarily fast, because then they can just do more proof of work.
Right. And so my understanding then is that another way of stating that is that the only guarantees you get in a proof of work system are probabilistic. There's no deterministic guarantee that the block is definitely final. If someone shows up later with a longer or better history, then the block goes away, and there's no block that's exempt from that.
Yeah, although you are exempt from it if you're willing to admit certain assumptions about hash rates and timing.
Sorry, can you go into more detail? What exactly do you mean?
Yeah, so I mean, if the network latency isn't arbitrary. I mean, if message arrival isn't arbitrary, but messages arrive within some bounded time, even if we don't know that bound.
Mm-hmm.
And if hash rates for every node are bounded, even though we don't know that bound, then if we wait enough blocks, we don't necessarily know what enough is, we won't be reverted. And there's like a proof that kind of shows that.
Interesting. Okay.
But all this kind of just says like, okay, we need bounded times, timeouts, bounded hash rates, bounded network propagation and bounded hash rates in order to guarantee that if we wait enough, block will be reversed. And that's kind of synchrony assumption that's required for both the safety and liveness of Bitcoin. So Bitcoin is a consensus protocol and it's an incentive mechanism, right? And it kind of is an extraordinarily simple consensus protocol and an extraordinarily simple incentive mechanism. And it doesn't do a lot of the things that we want from, both an incentive mechanism and a consensus protocol, which I think is not actually that surprising given how, remarkably simple it is. But, it's an extremely good pedagogical tool in my opinion. And so it's done a huge amount of value just by, putting these two things in the same place, right? The incentive mechanisms and the consensus.
I'm sure the Bitcoin maximalists will be really excited to hear you describe Bitcoin as a as a pedagogical tool. But I understand what you're saying. So let me ask you. So it's commonly described that the miners in a proof of work system play the role of securing the network. And I think to a lot of people, it's not really obvious what exactly that means. In what sense they're securing the network? Can you flesh that out a little bit?
Yeah, sure. So miners do work in order to secure the network. What that means is basically they add work to the blockchain in order to kind of make it like kind of tamper resistant, make it hard for someone to reverse the blocks. In proof of stake, there's like a different system. Instead of doing proof of work, we're gonna use coins in the protocol, like actually Bitcoins you can imagine, or Ether, or some kind of token, in order to create this tamper resistance, this difficulty to an adversary to attack the protocol. In proof of stake, the idea is that the adversary would have to actually buy tokens and attack the protocol at their expense like that. In proof of work, they would have to buy mining power and attack the protocol at their expense like that.
So this is a good time, I guess, to get into proof of stake. So what exactly is proof of stake? Can you just describe end to end how proof of stake works?
Well, I mean, firstly, proof of stake is a wide design space.
Mm-hmm.
And it's hard for me to describe end-to-end how it works because, I'd have to describe how consensus protocols work end-to-end and then how you could possibly incentivize them with coins
sure.
end-to-end. And that's a lot. However, I could describe to you the history of proof of stake.
Yeah, let's go with that.
So proof of stake started off with this great insight from this guy named Sonny King, who realized that maybe we could simulate miners by buying coins instead of hardware and putting the coins to work. And then this was kind of the thing that led to the birth of PP coin, which is the first kind of proof of stake coin. And then, proof of stake, it's always kind of been, this weird voodoo magic thing it was at the time, like a weird voodoo magic thing where somehow you just this crazy mining process that everyone was used to and participating in to mine Bitcoin. It's very real. You buy hardware, you plug into the wall, pay your electricity bills to earn your coins, sell your coins to pay the bills, and you have this like pretty like clear economic game with like a lot of, that ended up being really capital intensive. Proof of stake, instead you like just buy some coins and put them in something that doesn't necessarily consume that much electricity, and somehow it seemed weird, right? And then there was a bunch of variations on that on PB Coin, iterations on improving some of the problems that people noticed with it, namely things like, for example, if you made a bunch of blocks and if you chose the blocks right, you might increase your probability of getting a block being chosen for a block later. There was basically this thing called the nothing at stake attack, or nothing at stake problem, where you had an incentive to create blocks on all forks just in case at some fork won. Whereas like in proof of work, you can't. Every block costs a lot of work, so you got to be really careful about where you put it. And then there was this thing called the long range attack problem, which basically said that someone could buy up old coins and use the old coins to, coins that cryptographic keys to coins that no longer held by those keys, and use those to conduct an attack from a more kind of a block that's like further back in order to make a chain that's longer, and therefore would win in this kind of fork choice rule thing, right? Because back then, proof of stake really was just trying to emulate proof of work. And then I think that the main shift that happened between like that era of proof of stake and like what I think we're coming into now, like a modern era of proof of stake, is a shift from using coins as kind of risk-free kind of simulated miners and trying to make it difficult to game that and kind of have it work under a majority honest assumption. Is that we're kind of moving to a world where we're at least at Ethereum and there's a few other projects thinking about using security deposits rather than just like free coins. And so in this model, like you place deposits and then you participate in the consensus, and if you behave in a Byzantine way, you may lose your deposits. And so kind of as a result, the nothing at stake problem was kind of addressed because you had this deposit at stake. There's a long-range attack problem, which also has a very similar type of solution, where basically you never trust signatures from coins that are, no longer on deposit, because like only deposited coins mean anything. And that kind of led to this change in the trust model, where basically rather than authenticating everything from the Genesis block in the style of proof of work, you kind of need to have some recent information about who currently has deposits, or some hash that you can use to verify a proof about who has deposits in order to authenticate the chain. And so that's kind of like the history of proof of stake up until about like 2014. As far as maybe early 2015, and then what you have to kind of see is that even once you realize let's use security deposits, doing incentive mechanism design for consensus protocols is a really difficult thing, because consensus protocols are actually really complicated, and they're the whole world of consensus protocols that existed before Bitcoin looked nothing like Bitcoin. And there's really rather complicated protocols and research that explored this stuff, and where they didn't really think about incentives at all, and so we need to. And then I think the last 3 years we've been really working hard at understanding consensus really deeply, and kind of building consensus protocols that can be incentivized in a way that's kind of natural and that kind of works from both sides, right? From the point of view of what we know about consensus, and also from the point of view of the mechanism design. And I could go more into that, but I think that it's already gotten to a point where it's quite technical.
Oh, sure. This is a technical podcast, so I don't want to shy away necessarily from details. But one thing, I guess, just to kind of also frame for those who are not familiar with Ethereum. So Ethereum right now is a proof of work based system, and there's a plan. I don't know the exact timeline, but I'm guessing in the next year or so, to move Ethereum from a proof of work based protocol, which it currently is, to a hybrid proof of stake, proof of work protocol, and then eventually to entirely proof of stake. Is that correct?
Yeah, that's correct. Yeah.
Right. And so the first thing I guess I want to ask you is that, for the network the size of Ethereum, it seems like quite a risky transition. What are your thoughts about managing the risk of moving from proof of work to proof of stake?
Sure. Well, there's a bunch of different types of risk. There's kind of, the thing that for some reason some people are still worried about, but myself and Vitalik, who are the main people who really are pushing this at Ethereum, By the way, earlier you said I always lead at the proof of stake. It's really myself and Vitalik. We really work together on this. It's not really like either of us are really like a true lead or anything.
Right.
But so there's like this kind of like, firstly, there's this kind of fundamental technology feasibility risk, which we're not really concerned about at this point.
Mm-hmm.
There's like implementation risk, which is definitely somewhat concerning because, the protocol it's pretty simple, but also pretty complex. I mean, it's complex enough where you could easily see some software implementation problems leading to actual risk, right? And so obviously we need to make sure that like A, the spec is crystal clear and correct, and B, that like the implementation does actually match the spec and are compatible with each other. That's a lot of work. But actually, I think the biggest risk for moving to proof of stake isn't any of this. It's actually a more kind of political risk, unrest, and people being upset at change just because they don't understand it and because they A, are miners, or B, are Bitcoin maximalists, or any who are suspicious of proof of stake because they heard about and have been reading about nothing at stake and long range attack problems from the Bitcoinosphere for years. And so I think there's this kind of educational / political risk. And I say / because it's really, I think education will go a really long way, but I also think that there's an extent to which people's incentives, mean that like education is not really going to solve everything. But still, we think that proof of stake is like really important from the point of view of like increasing the usability and security and efficiency of blockchains, and also like from the point of view of its place on the scaling roadmap, because blockchain sharding is actually considerably less effective if you want to shard consensus with proof of work.
Right. So sharding is one of the pieces of also the Ethereum roadmap for scaling, but that's very challenging to do without moving to proof of stake, correct?
It's very hard to sample miners or validators to particular shards, make them responsible for them without proof of stake.
Right. So you mentioned
basically because you need to go to non-outsourceable proof of work and like kind of gauge people's mining power, and then assign them to shards in a non-outsourceable way, which is kind of very different from the proof of work model today. And at that point, you end up moving so much towards the proof of stake model that you might as well.
Right.
You might as well just do the proof of stake.
Right. So you mentioned though that proof of stake increases both the security and scalability of Ethereum. Can you go into explaining why exactly that is?
I said security, usability, and efficiency.
Security, usability, and efficiency. Sorry. Could you explain why that is?
Sure. So security thing. I mean, we kind of talked about it in a couple ways, but basically, like we're gonna have like better economic analysis. I mean, there's gonna be like the following the protocols actually in equilibrium, and we're gonna have like ability to show that actually you have to be unprofitable to attack the system. I.e., you can't attack the system and be profitable like you can in like say a proof of work system with like a majority coalition. And also we're gonna have things like finality, where you're actually gonna be able to have a point where you can say, okay, this block is like not going to be reverted in a way that is asynchronously safe, and that's something that's like not possible in proof of work today. So basically, there's like these security benefits, which very much mirror the conversation we were having earlier. And then there's the usability aspect, which is basically like lower latency. You can actually tell how much security you're getting. If there's like a partition, like you can immediately see that like you don't have all the hash power or all the staking power. You like know how much security you have much more clearly than you would in proof of work. I mentioned the latency. That's actually a pretty big deal for Ethereum and for blockchains in general. It turns out that people really like fast confirmations for their transactions. And then there's the efficiency question, which basically, by that I just kind of I'm referring to things like the dollars, the total fees and issuance spent for security, and the total amount of like compute network overhead that the blockchain actually uses. So like right now you have to imagine that there's tens of millions of dollars every day going into mining hardware, into miners' hands, going into paying electricity bills, like huge rigs, and that's a really high cost economically speaking, right? And that's like when I say like high efficiency, I mean both that cost in terms of dollars and also in terms of the bandwidth compute overhead. So there's we can get, I think, more security, more usability at much lower cost. And so I think it's at the end of the day a pretty big no-brainer.
Right. Yeah, and I think I remember reading figures along the lines of that the Bitcoin network every day uses as much power as I believe the country of Nicaragua. They may actually be outdated at this point, but it consumes an enormous amount of energy. And as far as I understand, proof of stake is orders of magnitude less in its energy consumption for the same level of security guarantees.
Yeah, of course. Same level of security guarantees. You have to, usually give a security model, but like absolutely, I agree, and I can talk about models where.
Sure. Well, so one thing that's interesting. So there are a lot of other blockchains that already are using proof of stake. Can you talk about a couple of them, and maybe if you've received any inspiration or kind of had any? Obviously, like you'd be looking at comparables and trying to see what's working right now and what the weaknesses are of current proof of stake implementations. Like how has that gone and influenced development of Casper?
Yeah, sure. So I mean, firstly, one of my biggest influences in terms of development of Casper and other proof of stake protocols is I basically have two of them. One of them has kind of been developed, kind of abandoned right now, but the other one is still kind of chugging along on its way to production. The second one is like Tendermint. Tendermint is this proof of stake protocol that Jake Kwan and now Ethan Buckman are working on, and basically it's a traditional consensus protocol that finalizes every block kind of before it makes the block, and so that like there's never any forking, and it's asynchronously safe, and it like uses security deposits, and people will like lose their money if they are caught being Byzantine. And it's basically an application. It's basically taking a existing consensus protocol, kind of modifying it and simplifying it a bit, and then applying very basic mechanism design, very basic security deposit incentives on top of it. Another thing that kind of inspired me is Dominic Williams' paper on Pebble, which is like a project I think he since abandoned, which also had like security deposit based quorums, and it was basically like it was really cool because it was the first real like sharding thing, and also one of the first security deposit based things that I looked at. But now Dominic Williams is working on Dfinity, and he's got a whole host of different ideas, and I'm sure that he's still going to be working on proof of stake stuff eventually, but I'm not sure if that's what he's doing right now. I'm not too up to date on his stuff, but other than that, there's kind of the classic pure coin next, they're kind of coins that I would say like didn't do or aren't doing a lot of the mechanism design stuff that I really have come to expect, but instead do have very blockchain-like consensus protocols. Unlike Tendermint or Pebble, which have more like traditional consensus protocols, which finalize blocks kind of one at a time, and there's never any forking. I kind of like both of these approaches, and have spent a lot of time like trying to unify them, and I believe I've been successful. Where basically like I have a blockchain that forks, and I get the same type of finality in the end that a traditional consensus protocol gets.
So you and Vitalik have both had some very vocal critics in the community who claim that Casper is very unlikely to be secure. Let me ask you, what do you think are the best arguments against Casper?
Oh, interesting. Yeah. Geez, it's too hard to understand. I mean, I think it's probably the biggest one, but I think that's something where we're really making a lot of progress, simplifying things, making it easier. Mm-hmm. I think that the complexity is probably the main thing that I think I can understand why people are turned off by the complexity of proof of stake. Mm-hmm. That said, the simplicity of proof of work I think is unrealistic. In terms of fundamental criticisms that people have, is people like to really worry about this change in trust model that I talked about earlier, where I mentioned instead of finding the most work from the Genesis block, we'll use a piece of actually recent information to authenticate the state. This changes the trust model somewhat because you need to actually have someone inside the network that you trust to give you a piece of information for you to authenticate. It's like the blockchain has a public key that changes over time, and you need to know what that public key is to send it a message or to even listen to it, right? And so that is a change in the trust model, which we kind of have to accept to move to a proof of stake world if we want to have good mechanism design. And people are uncomfortable with that, and understandably, because it's an additional point where it might fail. However, we call it weak subjectivity, and because it is weak in the sense that it's something we only do once, and the moment you have this information, as soon as you have this information, everything else is objective. This is like you get this public key once, and the process by which you update it in the future, you can kind of do objectively just by yourself without trusting anyone. The four choice rule is entirely objective. Once you have this piece of recent finalized information about who has security deposits. So I think that actually we sacrifice a little bit on the objectivity with this kind of piece of information that's required to authenticate the consensus, but we gain a huge amount, namely all the benefits we talked about earlier, as in return. And so I think that's a good trade. But people are uncomfortable with that. People are concerned about proof of stake being wealth centralizing, but I think that's really kind of a crazy concern because we've seen proof of work become extremely centralized, and the main benefit of proof of stake actually is that it makes it possible to hold the players more to account, which is why we're able to get better game theory kind of properties. If there's more accountability in proof of stake than proof of work, and they both have the same amount of concentration, then I think it's a no-brainer to go with proof of stake. But people think somehow that because proof of stake is more directly money than miners, which have to be bought with money and maintained with expertise, that proof of stake is less, kind of somehow more concentrated. But I would say even if that was true, the fact that more accountable because the protocol has more access to it really does kind of more than compensate for the kind of more concentration, right? There's basically, it's one thing to think about the concentration of power in a game, and another to think about what the rules of the game actually can do to constrain the abuse of that power, right? And my claim is that we can do way more to constrain the abuse of power in proof of stake than is possible in proof of work.
Right.
And also I happen to believe that in proof of work, especially with ASICs, you end up having extreme concentration of power.
Can you go into a bit of detail? What do you mean? First, can you define what an ASIC is, and then why it's relevant to this discussion?
Yeah, so an ASIC is an application-specific integrated circuit. It's kind of specialized hardware, and in Bitcoin, there's been this trend of building ever more powerful application-specific integrated circuits to basically solve these crypto problems in order to kind of mine Bitcoins. And so there's there's a small number, I would say two, if that, of ASIC manufacturers that make chips that are performant enough to really put a dent in the total mining power. And and I can really, let me put it this way, there's one or two ASIC manufacturers that supply future, will basically produce the future hash power. And then your relationships with these people determine your ability to succeed as a miner, because if you can't get the latest chips, and everyone else does, you can't get the hash power in the future. And that creates tremendous centralization. And there's been efforts in proof of work to do ASIC resistant proof of work, which has led to a lot of GPU mineable coins. Because GPUs are actually already kind of like ASICs in a way. They're already super specialized for a particular kind of task. And so if you could make a hashing algorithm that really suited to that, it's hard to get much of a gain by making an ASIC just for that. And in this case, luckily somehow, unluckily somehow, depending on how you think about it, what your perspective is, instead of having these two Bitcoin ASIC manufacturing companies, we have AMD and NVIDIA being the ultimate beneficiaries of all these block rewards as people, buy the hardware in order to participate. And so I think the fact that, there's this, I think the concentration of power in the supply chain for miners is worse than the concentration of power in terms of coin ownership. But, to some extent that's just my opinion, because in both cases with ASICs or GPUs, it's just two companies. If that, there's one of the Bitcoin mining companies definitely is the underdog, and AMD is only really allowed to exist because of Intel's antitrust concerns.
Sure.
Seems to be.
Okay. Well, so Ethereum already uses ETH for its proof of work algorithm, which is ASIC resistant, correct?
Yeah.
And so how much centralization is there in Ethereum mining right now as a result of being ASIC resistant?
Well, so I think that there's much less centralization in Ethereum mining because of ASIC resistance. However, people often freak out because of the mining pools, but I think it's kind of important to realize that ultimately at the end of the day, it's the distribution of cards that matters, not the ownership of mining pools, because mining pools, for now anyways, don't have lock-in. And so if they do abuse their trust, people will just mine another pool.
Right.
So it's hard to measure the decentralization of these things because you really need to basically go out and do like legwork and find who has what graphics cards mining. But people want to be private about this stuff. It's not the case that every miner is advertising what they're doing.
Right. Cool.
Some miners are mining in countries where it's like illegal for them to be doing it, and they're doing it as a way to like kind of preserve their capital, or like turn electricity into money or whatever.
Mm-hmm. Makes sense.
And so it's hard to say, but basically, GPUs are more widely accessible than ASICs.
Right. So I want to veer the conversation one more time toward a final topic, which is kind of about all the stuff, hype, craziness that's going on right now in the blockchain space. Now, you've come out on your blog and on Twitter as being very cynical, I guess I would say, about the mania right now around Ethereum and ICOs and blockchain hype in general. Let me just kind of give you the floor for a second. How do you feel about the hype that's going on right now surrounding Ethereum or blockchains in general?
So basically, I have a bunch of reservations because I think that like the commercial interest in the technology has kind of far outpaced the tech and the academic understanding of it. And a lot of people think that's like a great thing in some ways, and I think it is too in some ways because like it's exciting and we're learning a lot really fast because there's a lot of interest in something that we don't know that much about. But also, I think people are putting the carriage ahead of the
cart before the horse, I think is what you're looking for.
Cart before the horse, yeah.
The carriage before the steed.
Yeah. And I think that it's basically people are being kind of reckless because of the exceptional returns that they've experienced with cryptocurrency, because of the incredible amount of excitement. And we kind of see this thing where a lot of cryptocurrency projects are essentially communities around an idea, or which I think is in some way quite interesting and cool, because sometimes these ideas are really cool, and there's a lot that can happen in a community that's really excited about an idea. But sentiment can change. People could become interested in ideas. We could find out that actually a lot of this stuff is just solved by like this one simple idea, and then like a lot of projects are now useless. I mean, there's a lot of stuff that could happen where a lot of people's investment hopes could be dashed just because of like all the crazy uncertainty and unknown information and stuff that is all over the place. And I mean, the information asymmetry in the space is incredibly remarkable. I mean, the information that the market pays attention to and the information that devs pay attention to is entirely different, right? Like the miners, the businesses, the VC. I mean, everyone lives in their own world and has like very different kind of experience of the cryptocurrency space. It's really remarkable. And so all this kind of information asymmetry, uncertainty, combined with huge amounts of excitement and investment makes me kind of concerned, right? Especially when I go to random parties and I hear people talk about how they're buying Litecoin or whatever whatever cryptocurrency that I've never heard of, and or how like they've bought Ether and they changed their life, and they have these crazy stories from people who given the stage of the technology, very early stage. I'm not sure, maybe I'm wrong, should all be, or like I'm not sure that the ecosystem is ready for the amount of interest that it's getting. But maybe the argument kind of goes that like all that interest makes it more ready, right? It kind of pushes the investment pushes things faster. Everything kind of will happen a little bit faster, and because it needs to, right? Yeah. Because there's lots of people coming in and they're losing their private keys. They don't understand what crypto credentials are. Like they want to know what they're like asking you for their password. Like there's no login to the service because it's like a crypto service. There's this huge amount of like education and safety for regular users who aren't like cryptocurrency specialists. That like it doesn't really exist there, right? And people lose money like all sorts of crazy ways, and like a lot of it's quite sad, right? And it's just because the tech and the standards, norms, the kind of mature software just isn't really there yet. You tweeted earlier, Ethereum isn't safe or scalable. It is immature tech.
And having attempted to develop on Ethereum and in Solidity, I would actually have to echo that sentiment. What do you think of the way that people are treating blockchain now, and how long do you think it'll take until that changes? Like, how long do you think it'll take until Ethereum does become mature and something that you could sort of, comfortably point an average user towards and say, hey, this is ready for you now?
Yeah, I mean, that's a great question. I mean, I think that there's like a whole bunch of things that need to happen for me to get that point. Because when you say average user, you're really talking about millions and millions of people.
Sure.
At least, right? I mean, potentially millions.
Right.
I mean, let's say, and at that point, we're talking about scalability, like safer, higher level languages. Like things that give you like lots of warnings where you're doing something that's like not good practice, and all this stuff is kind of coming, but it takes time. I think basically, yeah, like developer kind of tools, culture, I think basically like developer tools and like the blockchain scaling are the main kind of things that hold it back. But I don't feel super duper strongly about my answer, so I might change my mind.
Sure, fair enough. So then I'd be remiss if I didn't ask you at least once. So what do you think about the ICO mania that's going on right now? Any overall high-level thoughts or predictions about what's going on in the space?
Yeah, sure. So, I mean, I think that basically a lot of people are realizing that raising funds with ICO provides a lot of benefits compared to raising funds with VCs. Primarily, the fact that you don't need to structure your entire business and operation and vision and plan around what VCs expect. But there's costs also. And there's also like, it seems very easy to raise huge amounts of money. But, there are costs. There's regulatory kind of uncertainty about the nature of these things. Like, are they securities? I mean, sometimes certainly seems so. Sometimes it seems less so. And the SEC has like a pretty clear mandate about securities and the investing public versus the general public. So that's kind of one side of the story. Obviously, the other side of the story is in terms of the actual products that are being funded with cryptocurrency. With these ICOs, and I would say that it's kind of like a mixed bag, and probably like not that different from normal startup success and failure rates. I mean, maybe actually you could argue that they have a lower failure rate than startups because cryptocurrency communities form around projects that ICO, and someone from that community will probably pick up the slack if the founders leave, which is kind of less likely to be true in a startup. But for the most part, I think that the ICOs are very questionable because a lot of this tech I think is incredibly difficult to build. I think a lot of the times people are coming in thinking that things are going to be much easier than they are.
Right.
But sometimes I am pleasantly surprised by people who have simple architectures that aren't trying to do too much crazy stuff and that seem achievable. That said, I often do things that people think seem unachievable, so maybe I shouldn't judge too much.
Yeah.
But basically, I think ICOs in some cases have been and are a really good thing that fund great projects and build communities of large groups of stakeholders who kind of participate in this shared thing together, and have. But I think that there's also cases where the people who raise the money maybe aren't that good at managing the whole community thing. Maybe there's upset expectations. Maybe people leave. Maybe there's drama. Maybe there's thing. I mean, stuff fails all the time. Cryptocurrency isn't an exception.
Right. Well, yeah, I think it's definitely completely nuts right now. It seems to be something of a frenzy, but I agree with you that it seems like there are both positive and negatives to what's going on right now in ICOs. And certainly, even if things right now are kind of unsustainable, eventually they'll kind of fall back into an equilibrium. What do you think is the sort of in the longer term? What do you think is the effect of all this ICO and the awareness of the public of ICOs going to have on the blockchain ecosystem?
Yeah, it's interesting. Well, actually, so I think that when something is funded with an ICO, it's much more likely to contain a token And so I think, therefore, like the public ecosystem will involve many more tokens than it would have otherwise. So, which I think actually is not necessarily a positive thing. I think lots of apps that integrate tokens maybe should just not integrate them and have the tokens represent like, an emotional connection to the project or reward points or something that's kind of more nebulous rather than like tied into the project at every level, right? At every possible opportunity. People like to integrate their tokens into their applications because it gives the token buyer some assurance that there's going to be a reason for people to buy them in the future. But that doesn't necessarily always lead to what I think is the best design. And I think that's actually my biggest problem with the ICO space is that I think lots of people are just taking products that would be great without tokens, adding tokens to them and making them less great products.
Right.
On the other side, lots of people making lots of money on ICOs and funding lots of stuff that maybe otherwise wouldn't have gotten built at all. And so it's hard to kind of weigh those things against each other.
Yeah, makes a lot of sense. Well, Vlad, it's been really fascinating conversation. Thanks for taking the time for chatting with me, and I look forward to seeing what happens with Casper.
Hey, my pleasure. Stay patient. It's going to happen soon.
Awesome. Will do. And thanks so much for all your hard work.